Hello, we will do the next experiment, which is experiment number 7 for 101 lab. The title is the gravimetric analysis of chloride. With this experiment, we start actually working on using the different techniques that is developed. Now, we are going to include the analysis technique. And so in this particular experiment, the prime definition is what is gravimetric. And then, of course, we know the term analysis, and then for the chloride ion. I'll first define the term. Gravimetric is an analytical technique used in which we take an unknown sample and put another prepared standard solution into it in order to form a precipitate. Now the question comes, what is a precipitate? A precipitate is the product of the combination of two solutions resulting in the formation of a solid. Now, once the solid is obtained, naturally it will be suspended in the solvent, and so we have to separate the solid from the solution. And in order to do that, we will use our filtration technique. The concept behind filtration is that the size of the particles must be smaller than the size of the pores of the filter paper. Then there must be some attraction between the solvent and the filter paper so that it can go off. And the third principle is that by gravity action, the solvent will separate out, leaving the solid behind on top of the filter paper. So once we get the solid, then we can, of course, transfer the solid. Normally, if you were doing it in a lab, we would dry it in an oven so that all the trace of moisture is gone, and then weigh the sample that is obtained, weigh the mass of the dried sample that is obtained, and then do the calculations. Now, in order to complete the calculations in this particular experiment, one must know how to balance the equations. So it involves chapter number 3, because formation of a compound, that is how to write the formula of a compound, is in your lecture 2, and then writing the reaction is in chapter 3, and then the amount of product obtained is in lecture 4, stoichiometry. So all those terms come into play here. And with that brief introduction, I'm going to share my screen with you so that we can start the experiment. Now, first, again, we go to open a new lab and go find the title for the gravimetric analysis of chloride. And so this is also one of the techniques used to find the formula of a compound that is there. And so you can see here the gravimetric, how they have defined. So go to the introduction, read up everything. We see that in this case, we have an unknown salt solution, and to that we are going to add silver. All sodium salts are water soluble, so they will exist in the form of ions. All nitrates are water soluble, and so they will exist in the form of ions. And therefore, when we dissolve the unknown salt with water, you get the ions in solution. To this solution, we will add a prepared known amount of silver nitrate solution. The end of the experiment hopefully will show by the difference in color. Then we will use the Buckner funnel to separate and filter out. Then we will weigh the sample. Once we get the sample, then by looking at the reaction, we see that 1 mole of silver requires 1 mole of chloride ion. and therefore you will get 1 mole of silver chloride. Now, from this, if you know the molar mass of silver chloride, then we can find out the percentage of the mole of silver chloride that was obtained as the product, because the definition of mole is mass of silver chloride divided by the molar mass of silver chloride, and then multiply that to get the moles of chloride, because we know that 1 mole of silver chloride requires 1 mole of chloride, and then convert the mole of chloride to the grams of chloride, and then find the percentage of the chloride in the sample. So now we go to the experiment. So over here, it says you get so go to the equipment, get a beaker that is 250 ml. Into that, right-click the mouse, and then you will get a dialog drop-down menu, find the unknown salt, and write down whatever the mass is. Don't copy what I am writing. So just put in there, then so after that, you have to dissolve. So you add water. Again, you right-click the mouse, and we want to add 100 ml. Water is at room temperature. Stir it to dissolve the salt. Now, once you do that, you've dissolved the salt. Once the stirring rod goes in, then go to the chemical and add the nitric acid, whatever the amount it says. And then you will again give it a stir to ensure that it's all mixed up. Then what you do is, next they say you get 100 ml graduated cylinder, 100 ml. So we have the graduated cylinder. Then we cancel that. We fill it up with the chemical, silver nitrate. Okay, there you have the silver nitrate. Now you have to pour this silver nitrate into the salt solution. So now let's see if to pour 5 ml or 20 ml. One technique is to get the burette and pour it in increments so that you can see the reaction that is taking place. Let me see if that works over here. And so I'm going to go and get a burette, a 50 ml burette. And I'm going to fill this up. It's 50 ml. And see if it works. Otherwise, you can just pour and decant. Also, but if you want to do it accurately, then you have to have. So you can see that. So between 5 and 10 ml increments. And as the precipitate forms, you will see that it is settling at the bottom. Continue until no more precipitate to verify the reaction is complete. You go to check the chemical properties of this particular So now I have added 20. So you can see that. I'm going to close it. Now, if you want to do it by, this is one way of doing it. And then, of course, you can check the chemical properties to find out how much unknown solution. You can get all the information, the product that is formed. And we can see that there is still a difference in the amount of the salt that is there formed. And so we have to continue to add, and you just say, okay. Now, another method I'm going to show you is again repeated from using the So here is a beaker. I'm going to add my unknown salt. So whichever you find convenient, do that. And then we have to add water, 100 mLs. I'm going to add the 100 mLs. Then we stir it. Then we add the acid. Now, the question is, why do we need to add the acid to this solution? One of the reasons why we add is the silver chloride precipitate is it's light and floats around, and it does not come together, or what we call as it does not coagulate. So acidity helps it to come close together and coagulate so that heavier particles will settle down. So once we do that, again, we make sure we stir it up. And once we stir it up, then we can use the pour and decant, and then you see I've added about, oops, let me, okay, I've added 50 mLs, and you can see as the particles are forming, you will see how nicely, because of the acid, it will settle down. And then now we have to keep an eye whether there is, again, we pour a little bit more and stop it. And we make sure that all the precipitate is settled at the bottom. Okay, so once we do that, you can pour it in and continue, check the chemical properties to see. So distilled water silver nitrate is 0.025 mole, and so most probably it's okay. So check your salt concentration should be 0, Cl concentration should be 0, and the AgCl concentration should be the same as that of the NaCl taken at the beginning. So once it is there, then you get the Buckner funnel. So there it is. So now we have, I've shown you the method with the burette to do it accurately. You can even use the graduated cylinder, which is much faster, and then get the Buckner funnel. And then all you have to do is pour and decant this. Now, in the laboratory, you will have to set up a filtering station. So we say pour and decant and transfer all the compound. You can see the silver chloride at the bottom. And you can, then once you finish that, so now we know that the silver chloride is in the Buckner funnel. So highlight the Buckner funnel, remove that, and then the drop-down menu box will ask you where you want to transfer the silver chloride into. So go to the watch glass or evaporating dish, whatever you like. You say watch glass, click on that, and you click on the watch glass or the test tube or whatever you have selected, and then say show the weight, and it will show you the weight of the silver chloride that is formed. Now with that, you can enter the unknown weight of the sample that you took, weight of the silver chloride formed, an approximate volume of silver nitrate solution you added. So you enter all this. Then the moles of silver chloride, I told you how. You have the mass. In my case, it is 10.749 divided by 143.32. Get the moles, then weight of chloride in the silver unknown sample, which is the same as the weight of the silver chloride, will be moles of silver chloride multiplied by the atomic mass of chloride ion. Once you get that, then weight of the chloride in the unknown sample divided by the weight mass of the sample taken, and multiply the ratio by 100 and answer the question, what happened as excess AgNO3 solution was added to the unknown chloride solution? You can, because you are observing the experiment, you can answer that. Remember, once all the observations are done, that the observation table is the only part that you can copy and paste directly. And you can change this to observation and calculations, because this is the calculation part in the middle. Once that is done, make sure you take the pictures of everything, put it in your lab report, use the result to discuss, and then conclude your experiment, and then finally do the homework and save everything in one document and submit it for evaluation purposes.